Today's title, obviously, no Big Bang Theory, and we'll get into why here in just a second. So real quick, I'm Artie Sluka. I'm the technical manager at Clean Slate over the AWS development team. Developer turned architect turned manager, not necessarily by choice, but it's a great role. I have a great team. With me is another Clean Slate, Daniel Schnipke, and Aaron Thomas, who also collaborated on this project with us. So three of us together came up with this problem and approach we wanted to talk about here. So when we talk about Big Bang migrations, I instantly think of my favorite sitcom of all time, The Big Bang Theory. When we talk about Big Bang migrations, we're talking about the kind that take 3 years. Someone was talking about migrations today, lift and shift, containerization. I'm talking the kind that we see in our line of work a lot, which is 15 to 20-year-old ASP.NET or end-tier applications that were bleeding edge back in 2008 that are now absolutely impossible to maintain. Can't support it, can't patch it, drop support by the vendor, massive databases that are huge headaches, can't deploy more than once a year. You know what I'm talking about. Much like Howard and Sheldon talking about this rocket for an entire episode only to watch it explode on the launch pad. That is what keeps execs up at night when they need to deal with migration projects. So this one that we were talking about was getting off of an end-tier application, going to the cloud, but going to brand new technology. Someone said earlier today, it's not about the technology, it's about the infrastructure. It is, unless you can't take your tech with you, which is what we see a lot. There's a lot of power in the serverless tech in the cloud. It can operate at scale. It can be a lot cheaper. It's a lot easier to develop on. We could do a whole presentation on why we would do that. But the key issue with a big migration effort for a big enterprise project, we've seen it many times, is at the end of it, you flip the switch and you hope it works. And this freaks executives out. Everybody wants to do this instead. Let's build a little piece. Let's invest a little money. Let's invest a little time. Let's release it to our people. Let's make sure it works and deliver it in incremental pieces. I mean, Agile was based on this process. Small changes, we can move quickly. So why don't we just do that? And the reason is always the same. It's we got to synchronize the old system and the new system. We can't just cut it all over. They still have to both work. We only want to move a few people over. And always, it is complicated, expensive, and it's generally terrible, and a lot of companies bail out. Unless you don't have a choice. In which case, I will hand this over to Mr. Aaron Thomas to tell you what we were dealing with.
Yeah, so the environment we've got standing up, as it says here, is a 25 plus year old .NET Framework app. It's almost fully unsupported. Requires IE Edge mode to run. They've only promised that through 2029, so we're getting near the end here. But we've tried some other things along the way. I've been working here for 4 years, and we've only been working on the latest iteration of AWS accounts, but there's been one before that, 2 generations of Azure before that. And the fun part is the center of the universe never changed. It was always the legacy applications, SQL Server database. No matter what we did, everything had to write everything back to that location. And so we've gathered around 5 terabytes of SQL Server data in production, and having fun with this project to figure out how to sync that across to Dynamo as we need it, as a one source of truth for everything. So yeah, we've had all kinds of fun taking a look at all these accounts and seeing how we can convert everything over.
So that was the challenge. We're going to our bread and butter, which is serverless tech, API Gateway, Lambda, DynamoDB. Our favorite, monolith to microservices, one big database to 12 smaller-ish databases with single table design. So that's one of the tricks too, is I got 300 database tables. I don't know how many you have. I made that number up. It's a lot.
Yes. It is a lot. It's like 176 or something like that.
So here's the challenge you're into doing that. So for starters, we have done this kind of thing before. We did it once with a big Oracle instance at another client. And we actually got this to work. Yeah, I will explain this picture here in a second. But we were able to use the AWS database migration system to do actually, it pulled data out of Oracle and dumps it raw into a DynamoDB staging table as is, column names, attributes, everything. Now, the problem is if you want to do that with a spread out relational database, you have to somehow flatten the entire thing. And so you can get it dumped into one giant structure that supports 15 different object types, right? So what we did, okay, no problem. For going from the old system to the new system, we'll dust off the DMS, we'll create our views. That was our best way to structure the data, and we'll pipe it over. But much like this scene from the show where Sheldon came up with the idea of let's play the campaign for North Africa, a board game that takes like, I don't know, how long?
No one's finished it.
No one's ever finished it because it's hundreds of hours to play. We were way deep into it when the DBA read the documentation and said, well, guess what? That doesn't work for SQL Server. And we looked at it and went, shoot. Well, that was a dead end. DMS was out. So now what do? We still have the same problem. We just had to move it around. We still have a big relational database. We still have to consolidate to a single DynamoDB table. So we wound up switching to a home-rolled store procedure model that I will let Aaron speak to.
Yeah, so instead of creating SQL views, we ended up creating a stored procedure model where we have what we call scenario procedures that are attributed to features in the new application that inherently know how to convert that data from one system to the other and are called on demand on a per record basis. And from the legacy, pulling everything from the legacy system to the new, that gives us this this ability to use input parameters here. So we can control how much data we're flowing at one time, how often we're controlling it with Lambda or with EventBridge, cron schedules, all that kind of stuff. And then also it mentions the data purge here. So we had a project about a year ago to identify some old data. We have data from like the late 90s, I think, still in this database. So the data team went through at the time and made some scripts to identify what data we could potentially get rid of. And because of that project, we were able to tie our new store procedure model here into that. So now instead of deleting that data, we can just simply ignore it. And that data never makes it over into Dynamo. And it naturally dies off, but the old application can still see it if they ever need it until we're done with it. So
awesome. More on that to come. So scale problem, of course, you can tell by now I cracked myself up because I thought this was a funny picture for this, but you can hear Sheldon going bazinga in the ball pit. But this represents Daniel getting ready to open the floodgates in the stage environment. Take it away, sir.
Yeah, so getting this set up, we got it set up to do a few records, but we need to have everything pulled over before you can start using the two systems in parallel. And so scale the problem is tens of millions of records. And then once we have that initial massive load in, then we need fairly frequent updates to keep things close enough that both systems are usable. So only thousands of records. And there are a variety of points that can break during this.
Yeah, you can see them, right?
Yep.
I mean, you can start out if you want, but ultimately the fun part about this is there's also the extra challenge of the business wants changes to how the new application works and how the data is structured, and we have the capability with the stored procedure model to let that be available as a thing, and to be able to I can't think of a good example off the top of my head right now, but to be able to modify that data, which we were already doing anyway, but in such a further way that the behavior of the new application can actually be different enough and beneficial to the business while still supporting the legacy system. And then here it mentions the circuit breaker pattern. So we also have to make sure that as we're changing that data, we recognize that change was made, because the other direction of our data bridge, as we're calling it, has to recognize that it came from that original system, so we don't end up creating infinite data along the way. So
that was probably our longest whiteboard session or multiple
absolutely.
sessions.
Absolutely.
Was we change it here and it goes here and it comes back, and how do we stop it from doing this? And some of you guys know we talked about this forever, and we did figure it out. More on that. Another thing is it has to be quick enough. This sync has to be to the point where users can see it. So it shouldn't take forever, and it shouldn't be super complicated either, unlike this set of Klingon boggle that just, the idea of it cracks me up. So it made it into the slide. Now, we called it the key problem, even though we're putting the emphasis on the wrong word. Sheldon had key problems and walked out of his apartment, but that's not what we're talking about. We're talking about keys missing in one system or the other.
Right. So those various generations of applications over the years have, at way early on they were using code generation, C# code generation. So all of that had version fields enabled, which is, I would love to shake the hand of the person who set that up. But once they stopped using code generation, those fields disappeared. So sometimes we have primary keys. Sometimes we have no useful primary keys, and we only have dates. Sometimes we only have inconsistent dates. So we've done everything from modifying tables in place to add versions, or if it's too large to do, we've come up with other solutions like creating parallel tables and things like that, and modifying the legacy system itself, because that's the other benefit of this is we control both ends. So if the legacy application needs to change in a way that's imperceptible to the user, then we can do that to support the new efforts. So
on top of that, with the IDs on the new system, instead of carrying over these legacy IDs and continuing to bring it along, cleaning the slate and going with ULIDs. All right, so what did we build to fix this? Got two directions involved. We have the new system going to the legacy, and we have the legacy system going to the new. For new to legacy, start there with a cross-account DynamoDB stream. This is a feature they added in February, right when we needed it, so that was nice. We added a flag to every record in the database for Dynamo, called a consistency state, and you set it to something that you know, so that when you are tracking this on the Lambda that's feeding off that stream, you know that anything that isn't matching that, to just discard it. Then from there, we have Lambdas that go off to stored procedures into the legacy system. The end result is that this goes really fast. Near real time is the term we're using for it. But you enter it in the new system, and it'll be in the old system by the time you can refresh the page. The other direction is a little bit slower, but still good. For that one, we have stored procedures that load up some number of records and at some timing based off of a cron job. From the versioning that Aaron was talking about allows us to get a specific set of records as they change. And this also helps us with reliability, where we store what version we're at, and if we don't succeed on writing stuff over, then we just don't save the new version, and we can be able to repeat that spot until we get it, until we're able to change and get things correct. With having a huge initial data load and then having users want to consistently use the system afterwards, the solution there is that we can change the parameters, and so we can set it up for really large batches at first, and then scale down the batch size and scale down the latency interval to much smaller once the system's rolling for good. When we have it go this direction, we set that consistency flag to being a different value so we can recognize that, no, this one does not need to come back around again.
Stop sending it.
Yep. Dealing with keys. So the new system has its new numbers of keys, and they don't have IDs in the old system. We've got to figure out how to connect these together. What we ended up doing with that was a DynamoDB table in the legacy AWS account, and that one contains records that give us the ability to get back those ULIDs when you're trying to do the legacy to new direction. And you do that on the new to legacy direction writes so that those keys are available for the other direction.
Staging table.
Yeah.
Yep.
For the front end, the idea here is the front end largely can just use the system. The consistency state is available if there's something that starts to be a timing issue. They have that information available, but most of the time the user doesn't care too much unless they're getting really choppy with trying to change the record tons and tons of times really close together. So, because if the user's changing the record and wants to edit it again, both of those changes get sent through the stream, change the old database, and then the next time it syncs through, it should be fine. If they manage to get that just wrong, they might see weirdness momentarily, but it will correct itself. Here's our architecture diagram.
Kind of fuzzy, but
So what we got now, let's see, what time is it? All right, we got 10 minutes. This is our last slide. We'll talk through the fun, and you guys can ask any questions, blow holes in any of this architecture, or return any favor about blue-green deployments if you want. I'll give you that one.
User enters in the new system, enters some information, API gateway lambda to DynamoDB table. Standard serverless stuff. This is how the new application just runs, and once the legacy system goes away, we skipped over it, but part of the nice thing is that when we're all done here, the new system keeps running, and we just turn all this off, and it goes away.
Push the delete button.
Yep, push the delete button. But until we get to do that, we got the DynamoDB stream, toss over Lambda that throws things in the legacy.
So this is our newest, well, other than the new one, this is our previously newest generation of AWS. So that account, our database is stored on SQL Server in a data center. And for networking reasons, the old account is already hooked up to that data center. So it was a lot easier to just keep using that account instead of setting up the new accounts to also talk to that data center. And also it added the benefit that we already talked about where when at the end, we can just shut all this off. We don't have to remove a connection that would fail if you stopped it and things like that. So,
all right, so that's that one direction. Done. It goes instantly, very fast, whoosh. Then we have EventBridge, fires off Lambdas that then pull the SQL Server, stores the legacy version numbers in here. So it says, all right, which version number are we at? Grab the newest stuff if there is any. And then ships it off to the DynamoDB. From there, error handling is some other fun parts where we've got, we can have those Lambdas can send off errors. Another cross-account DynamoDB stream will mark those records as errors instead of consistent or pending. And we can track off that for notifying people for various who wants to know if there is an error.
So part of the microservice monolith to microservices exercise is something the industry calls domain modeling. So our microservice approach. So on the left, that is representative of one microservice. We'll probably have about 12 when we're done. Each one of them has their own DynamoDB table. So it's simply an exercise of finding the relevant data in the old system, creating a stored procedure that consolidates all of it into a flat structure, and that is what goes directly into the DynamoDB stream. So we've done that. That's a pen and paper exercise. Now it's more of a Kiro exercise because it's really good at helping us with that. But we've done that. We do that for every single one of these domains. All right, so just like the rest of Clean Slate here, I'm the last of the people to present this, but we are definitely hosting the virtual office hours tomorrow, 3:35. If you have seen something today from our team that you want to talk about, or if you've got general AWS problems, we got a lot of pretty good AWS people. That QR code gives you a link to all of that. We'll be online. Like I said, what did David say? We can talk about AWS. We can talk about Dungeons and Dragons. Yeah, right. We can do all of the above if you wish. So definitely appreciate everybody coming out today, and hope you guys have a great rest of the day.